Oh, hi, good morning, everyone. It's Tuesday, January 22nd, 2013, and this is a commentary to Lecture 2 on Sustainability Modeling. I have a few things I wanted to say, so I had to write them down. So you'll find in the Facebook page and also in the Dropbox page the Lecture 2 materials, the video and the lecture itself. I've posted already. There's also in the Dropbox, you have the readings, which I want to talk about briefly. There are a couple of things that I put up for reading the class. One is a chapter 1 from a textbook that I actually have here. I want to show you. It's Modeling the Environment by Andrew Ford, and I have the full book here, and the author makes a couple of his chapters available off his website free of charge, so I thought I could use that. And it's actually a pretty good introduction to modeling and the modeling process, and it's got some nice comments about the system dynamics approach, which we cover in this lecture. So the book by itself, I will post a reference in case anybody wants to take a closer look at it. The book is nice. It focuses primarily on environmental modeling issues, which are only a part of sustainability modeling issues that we'll be covering in the class. So it's probably a good reference to have, but it's certainly not mandatory. It's available from Amazon. It's fairly cheap. It's like $37, and the book's pretty good. So in case you want to take a look at it, I'll send you guys the Amazon site in case you want to take a look at it. The other thing the other reference I posted is a paper by Richard Toll, which provides a fairly nice overview of the sort of the bigger picture of the use of models in policy making processes, and some of the nuances and some of the characteristics of different modeling approaches that I think it's good for you to read, because we're going to be getting to these types of integrated models as the class progresses. So that in terms of the references. I wanted to say a couple of things on the modeling lecture and the modeling process. Most people tend to confuse models with just the sort of the computer simulation software. So people will call Vensim a model, and really Vensim is not a model, nor are any of the other software modeling tools that are out there. These are just software modeling tools. They're not models themselves. A model is a much broader concept. It involves a lot of thinking and a lot of putting the things together. And in this lecture, I make the case for modeling being both a science and an art, and I think that's very well the case. I wanted to emphasize the fact that models are really used to help us, organize and think about the dynamics of systems. And the software tools are just there to crunch some numbers, give us some results, and help us understand better. But they're not the end in itself. And more frequently than not, I'm sorry to say, we find that people tend to assume that the model is the end product. So you'll see consultants, you'll see people in industry, people in government, sort of developing these models as if that were the answer to the issues. And modeling, the development of models is just one of the first steps that you do to start thinking and to start making more detailed quantitative assessments about the dynamics of these systems. So a lot of people fall into the trap of that's one of the first traps that I mentioned in the lecture, is thinking that the model is the end of itself. It's not. It's just a step. I think the second big trap that I see happening more and more frequently is the one that I wanted to point you against or away from is the issue of trying to fit the problem to the model as opposed to modeling the problem. So you'll see, and if you do a literature search, if you go into any field, if you go into economics, if you go into the environment, if you go into demographics, you'll find that there's a fairly big community of models that are established. Okay, and then the easy trap to fall into is to try to, if you have a problem in any of these fields, is try to fit your problem into the model. So that's so it's easy to do that, because then if you're able to do that, or if you think you're able to do that, what's going to happen is that your model is going to give you an answer, okay? And then you're going to be happy with this answer because you used an established model, and that tends to be a mistake. And it's something. It's a source of constant debate. Model developers, people that have developed these models, will fight to the death to make you believe that their model is the best thing, since water in the desert. One of the reasons that I wanted to do this class is to really instill in you the notion and the ability to, do it the other way around. Think about the problem, develop the model based on the problem, and then use, some simple tools that are out there to develop uniquely suited models, which I think is the way to go. So that's going to be a little bit of my commentary. Let me see if I have anything else here in my notes. I think that's pretty much it. So please do the readings. I hope you enjoy the lecture. And if you have any questions or any comments, I left a couple of things for you to do in the lecture materials. Please post them on the Facebook page. And have a great week. And I look forward to receiving your comments. Take care.